course Programming Language Concept. In today's lecture, we are going to talk about the decision control structure, which is one of the most important topics in any programming language. So you have to keep the decision control structure in your mind, and you have to learn this decision control structure and then apply decision control structure in any programming language. So these are the topics that we are going to discuss in today's lecture. First of all, we will generally look at that what is decision control structure, and then we will talk about the if statement and if else statement, which is one of the uh, types of this decision control structure. And at the end, I will write some programs for the practice session as well. These are the references, so you can find these topics in detail how to program, chapter number 2, and in Robert Leffer object oriented programming, chapter number 3. These are the activities, lecture and the Maria's point activities. Now, objectives and outcomes of today's session. The objective of this lecture is to introduce 3 types of decision control structure. We will see that what are those 3 types of decision control structure, and based on it we will apply these decision structure in writing our program. Outcomes of this lecture, it means by the end of this lecture what students are going to get. So the outcomes of this lecture is that students should be able to understand and analyze 3 different types of decision control structure. You would be able to understand these 3 types of decision control structure, and then you apply the decision control structure when you write a program. Standard input. Now, before moving to uh, the decision control structure, let's talk about the standard input first, and then we will start the decision control structure. Remember that we can assign value or we can store value in variable in many ways. One way is to declare a variable and then assign value. Second way is to initialize a value. It means that declaring variable and assigning value at the same line or at the single line of code, that is basically called initialization. So the second way of storing value in any variable is initialization. The third way that we're going to discuss right now, that is the input. So basically we call this as standard input. Now let's look at the standard input and see that how can we store value in a variable using this standard input. Now, if you look at the point number 1, by default, the term standard input refers to the input given via keyboard. Now, via keyboard, it means that we have to supply or we have to store value in a variable through the keyboard. Normally, during runtime or during the program executes, it is going to ask us some values that you have to put into variable. So the standard input way is one of the ways through which we can store value using keyboard or through keyboard. Second point says C++ uses cn statement, cn stream object to get standard input. Now stream object, it is basically, if you remember in the program, the first line of our program is always begin with including header file, and that is IOStream. We include IOStream for the same purpose because we are using 2 of its object. One is cout. Now normally cout is used to display something, and the other one is cn. We will work on the cn and we will see that how can we use this cn object stream. So basically we include hash include IOStream. We use this line of code in order to include the header file, and this cn stream object is actually define an IOStream header file. That's why we are basically including IOStream. We have to include the IOStream header file in our program because it uses, again, it uses 2 of its objects. One cout for displaying something on the screen, and another object for taking input from the user during when the program executes. The word CN stands for console input. Now console CN is basically console input. Console input is basically our keyboard. That is the keyboard device, okay, or the input device. So we will supply some value, we will give some value, and that value will through the keyboard, and that value will be stored in a variable. Now C++ handles standard input by applying the extraction operator with CN stream. Now students, keep this thing in your mind that here we are using extraction operator or get from, we also call it get from operator. So this operator, this double greater than sign, greater than, in programming we call it extraction operator. Normally extraction operator are used in conjunction with the CN stream object. So we use this for getting input from the user. Now the operator must be followed by a variable. This operator, the extraction operator, it must be followed by a variable. Just like in this case, you can see we have the CN stream object, then we have the extraction operator, and then we have the variable. Variable must be terminated by the semicolon. Now, the variable is used to store the input data. Normally, we use this variable in order to store some value. Let's talk about this standard input in a more detailed way. How can we use the standard input? I mean the syntax. You can see this is the syntax. You have to use the CN stream object, and then you have to use the extraction operator, and then you have to use the variable name. Syntax, generally this was the syntax. Now let's try to, syntax mean the structure. How can you use the standard input in your program? Now this is basically the explanation of each of the construct that we use for the standard input syntax. First of all, we will look at this, what this CN means. As I told you, this is console input, and it is the name of the object used to get standard input. You will learn more about the object in classes in your second semester. Just keep this thing in your mind and take it on faith that basically CN is what it is, an object. Because if we are going to explain, or if we are going to learn the object in classes in today's lecture, then you guys will be confused. So never confuse about this. Just take this CN on faith that this is basically the object, and we use this for the standard input. This sign or this special symbol greater than, when it is used with object, it is actually called as extraction operator or get from operator. Get from operator. Now get from where? Get from keyboard, and then the value will be stored in the variable. It gets the input from CN object. Okay, the CN object, it means that CN console input object then stores the input in the variable. So the left side of this sign, the um, extraction operator, must be an input stream like CN. Like you can see here, this is basically on the right side we have the variable, and on the left side we have the CN object stream. So keep this thing on in your mind that the object stream must be on the right side of the on the left side of the extraction operator, and variable should be on the right side of the extraction operator. You can look at this point that the right side of the extraction operator must be a variable of simple data type. It can be even the type of the variable can be integer, it can be float, it can be character. And var is basically the variable. It is the variable in which the input value is stored. Now you can look at the diagram here. Suppose this is our computer, and this is the console input device that is actually the keyboard. So this CN takes a value from the keyboard. CN object takes the value from the keyboard when the program is in execution, it takes the value from the keyboard, and this extraction operator passes the value to where? To the variable. Look at the direction of this symbol. The direction is toward the variable. The direction is toward the variable. It means take the value from the keyboard. The cn object is going to pass it to this extraction operator. Extraction operator is going to pass it to the variable. So let's try to write a simple program in order to manifest this theoretical background and apply there in a practical program. Let me include all the header files. Hash include IOStream. Now for using cn and cout, we are basically including the IOStream using namespace std standard namespace. It's a basically container, and we have the main function. First of all, let us try to recall that how can we store a value in a variable. So we can store a value in a variable through different ways. One way is to assign value in a variable like this. So this is basically the assignment statement. Through the assignment statement, I have assigned a value, and when I print out or print the result on the screen, I can see the value of 5 would be there on the screen, on the terminal screen. So we will write this cn and we'll store this program, and then we're going to compile the code, and let's see. Now you can see we have stored a value, and that value is actually 5 in variable a, and then we display the value cout a, and then a, the value will be printed in using this a variable, and this is basically this message would be printed, and then the value will be printed in this line. So this is one way that we can store the value in a variable. Now here we have used one of the objects of this IOStream file, because the cout object is actually, it is defined here in the IOStream. That's why we have to include the IOStream header file in our program. The next way that we can store a value in a variable is using initialization. Now this is the initialization process. Here you can see that at one line I have declared a variable, and then I store a value in the variable. So this is actually called the initialization process, and when I run this program, you will see the value of the a on the screen. Here you can see the value of the a is what? That is a equal 50. Keep this thing in your mind that if you want to print the value, then do not enclose the variable in double quotation, because it's going to print you the same thing. Let's assume that here we store this variable a, we store this variable a this way, or we basically enclose the variable a in double quotation. So it's going to print us the variable name only. It's not going to print us the value of the variable. Let's try to run this code and see the result. Now you can see the a itself, or the variable name, has been printed here. So if you want to print the value, do not use this double quotation. Let's try to run this program again and see. You can see the value is printed here. Now this is the second way. The third way is to ask the user when the program is in run, or when the program is in the execution, the program is going to ask you or request you to input some value into the variable. Now let's try to work on this way using cn object. But before this, let us print a small message. Please enter a value in variable, so that user should know that what they have to do. If you are not going to print this statement, then the user is going to be confused. Even you can also be confused. We will see the program without this cout statement as well. Now after this, what next you have to do is that you have to use this cn object, and then the extraction operator. Remember, this is insertion operator and this is the extraction operator. Look at the direction of this operator. It means take this message, okay, and pass it to where? Pass it to console output device, which in this case would be the monitor screen. So, but here you can look at the sign is toward the variable, okay, and what is the variable? A variable is a. It means the value will be coming from console input device, that is keyboard, and it's going to be stored in variable a. So let's try to run this program and see. Now here you can see that I have not assigned, or I have not initialized the variable itself. So in this case, when the program runs, it's going to the program is going to ask me some value, and then I'm going to put that value, and then the value will be printed on the screen. So let's try to run this program. Now here you can see the program is waiting for us. The moment we supply a value, let's suppose the value is 60. The moment we press enter button, it's going to store the 60 in variable a. So let's try to press the enter. Now when I press the enter, you can look at the output here. The output is basically the result of this statement, okay. So now let's try to remove this statement and see that what happens if we run this program. Now you can see here, we don't know that what we have to do, only the cursor is blinking. It means that it is quite good programming practice that before using the cn statement, you have to print a message for the user that what he has to do. For example, if I enter 50 here, and now the control is where? The control is in this statement. The moment I enter, I put 50 and I press the enter button, then this statement is going to be executed. You can see a, that's equal to 50. So this is basically how you are going to use cn input in your program. Now to recall this or to summarize this discussion, we can store value in a variable in 3 different ways. Number 1, to declare a variable first and then to assign value to that variable. Second is the initialization. Okay, third one is the standard input. If you are using standard input, then do not assign value to a variable using assignment statement. Similarly, do not initialize the variable, only use the cn. Okay. So I hope that you have got the main point of the standard input, and I hope that how can you use this program in how can you use this standard input in your program. Now one thing more, that this on the right side of the extraction operator you have to put the variable name, and on the left side of the extraction operator you have to use cn object. Just like here, the cout object, okay, on the left side of the insertion operator we have used the cout object, and on the right side we have used a simple string, and we also have used a variable name. So I hope that you have got the main idea of standard input. Now the next thing, the decision control structure, the next topic that we are going to discuss, that is decision control structure. Now decision control structure, what does it mean? Basically, decision control structure controls the structure of your program statements by using some decision. Okay, like normally in our daily lives we take decisions, and based on the decision we change our direction. For example, if today is raining, then I'm not going to go to university. If there is too much traffic on the road, then I'm going to change the direction. Now here what we are doing, we are basically we are changing our decision. So in the same way, this can be applied in programming as well. Now programming, so far all the statements, or the sequential based, means neither statement is ignored or it is skipped by, but all the statements are executed one by one. But there are certain times that we can change this structure through some decision, and we will see that how can we do this. So for this we are going to study this chapter, the decision control structure. The number one point here in the decision control structure is a statement used to control the flow of execution in a program is called control structure. Now, control structure, with the help of control structure, you can control the flow of execution in a program, because our program will consist of many statements. It may consist of 3 statements, 4 statements, 5 statements, okay, 6 statements, even 10, 20. So this control structure is actually controlling the flow of execution in a program, how the different statements are executed or how they are run in our program. The second statement, the second point in this decision control structure says that instruction in a program can be organized in 3 different kinds of control structure to control execution flow. If you remember in the first lecture, second lecture, we also talked about this fact that we have 3 kinds of control structure to control execution flow. We will talk each of them in quite detail in coming slides. Programs are executed in C++ in a sequence, but we can control the execution of C++ program by using any control mechanism by which we compare things and come to a decision. Now, programs are executed in C++ in a sequence. Normally, all the programs that we have written so far, all the statements are executed in a sequence, means all the statements are executed one by one, okay? But you can also control the execution, or you can control the flow of execution of these statements in a C++ program. It means that based on your choice, what statements you are going to execute, what statements you are going to ignore. You can do this with the help of this decision control structure in program. Now, by using any control mechanism by which we can compare things and come to a decision. So here we are going to talk about this comparison operator as well. We are going to work on the relational expression, okay, because we will compare some values, and then based on comparing those values, we will come to a decision, and then based on this decision, some statements will be executed and some will be ignored. We will see them when we write program. This involves using some operation called conditional statements. As I told you, that here we are using some relational operators, and these relational operators are used in condition. So a condition would be made first, and then based on the condition, if the condition is true, some statements will be executed. If the condition is false, then some statements will be ignored. So these are basically different types of control structure. Number one, sequential. If you remember in the second lecture, we talked about these things as well. Sequential statements or the sequence, selection, okay, repetition. First of all, we are going to study the sequence, then we will talk about the selection control structure, then we will talk about the repetition. There is another control structure as well, and that is function flow. We will talk about the function after few lectures, but so far you have to keep these 3 things in your mind, that normally programs are executed using these 3 different control structure. Number one, the first thing, sequence control structure. Now sequence mean ordered, okay? Every statement that you write will be executed in an ordered way, or in a sequence, or in a linear way. For example, first of all, statement number 1 will be executed, then statement number 2, then 3, then 4, then 5, then 6. I'm also going to write a program for this, and then you will understand the sequence control structure in quite detail. So look at the point here. In sequential structure, the statements are executed in the same order in which they are specified in program. in which they are written in the program. Remember that in sequential structure, when you are using sequential structure, all the statements are executed in the same order in which you have written them, in which you have specified them in your program. The control flows from one statement to other in a sequence. Okay, so sequentially each of these statements will be executed. All statements are executed exactly once. Now keep this thing in your mind, that the statements that you write in sequential control structure will be executed once. No statement can be executed for 2 times or for 3 times. All the statements will be executed exactly one time. Now this means that no statement is skipped and uh, no statement is executed more than once. Also, you have to keep this point in your mind, that if you are using sequential control structure, if you are writing a program using sequential control structure, no statement will be skipped or ignored, and no statement executed more than once. You have to keep this thing in your mind. Suppose let's look at the example first, and then after this example we will look at the flow chart, and then I'm going to write a program. Now example, suppose a program inputs 2 numbers and display the sum on the screen. The program uses 2 statements to input numbers, one statement to calculate the sum and one statement to display the sum. We will look at this point here. The program uses 2 statements to input numbers, one statement to calculate the sum and one to display the sum. We will see this thing. These statements are executed in sequence to find the sum of numbers. Okay, if you want to find the sum of numbers, then you can uh, use this way. All statements are executed once when the program is executed. As we have discussed in the previous slide, that all the statements are executed exactly one time. No statement is executed for 2 or more than 2 times. It is an example of sequence control structure. First of all, um, we are going to discuss this, and then I'm going to write a program for this sequential structure. Now this is the flow chart. You can see, suppose these are the different statements. Flow chart for sequential structure, statement number 1. Now look at the direction. The direction is from here. This is the execution flow. This is called the execution flow. This is how the statements are run. This is how the statements are executed in the program. You can see statements are executed one after the other. So this is called sequential statements. Like first of all, statement 1 will be executed, then statement 2 will be executed, then statement 3, then statement 4, and at the end we will have the terminating point of the program. So now let's try to write a program and run the program in a sequential statements. Assume that I have 3 variables, so I have declared 3 variables in one line. You can also declare 3 variables in separate lines like this. These are the different statements. 3 statements are there. Okay, and after this, let me cout print a message. Please enter value in A. And line manipulator is used. I'm going to use the cn object for input. So here A will be the value in A will be stored, and then I'm going to use another cout statement in order to print a message to the user. Please enter value in B. And I have to use this extraction operator and then B, and after this I'm going to use C. Now in C I'm going to use this expression A plus B. So whatever the value user is going to enter in A and B, that value will be stored in these variable A and also in B, and then here it's going to calculate the value of A and B. A single value will be evaluated, and that single value will be stored in variable C. So let's try to the sum of the sum of value a, whatever the value is stored in variable a, okay, and whatever the value is stored in b, that will be printed, and equal sign, and then we are going to use the C. So now these are basically called sequential control structure. How this program is going to be executed: first of all, this statement is executed, then this is executed, then this, then this, then this, then this statement will be executed, then this statement will be executed, then this statement will be executed, and at the end this statement will be executed. So this is what we mean by that the program executes all the statements one after the other, and this structure is called sequential structure. Now if we run this program, we will see the result here. You can see because here I have used the cn object for storing values, okay, that's why it is waiting for me. When I enter a value here 40, okay, and I press enter, what happens? The control will transfer to the next statement. Here it's going to print this statement, and then the control will be transferred to this this statement, okay, and then again it's going to wait for me. Now here it waits for me. I put the value, this 40 will be stored in variable a, so when I enter, you can see the control transferred to this statement, okay. This statement basically print a message on the screen, and after this statement the control is now in this b, in this statement, okay, where we have to put a value, and that value will be stored in variable b. So if I put a value, let's assume that the value is 60, and I press enter, the control will directly come to this last statement, and it's going to print us the result. Now you can see this is the result. The sum of 40 plus 60, that's equal to what? That's equal to 100. I hope that you have understood the point here. The sequential structure flow chart, as well as through the example. Now let's talk about the other, the second type of control structure, that is selection control structure. So our focus in this lecture would be on the selection control structure, because we have done some programs on the sequential structure. So this is the selection control structure. Now let's see that what this control structure says. Basically, selection control structure, a selection control structure selects a statement or set of statements to execute on the basis of a condition. You have to keep this thing in your mind, that there will be a condition, okay, and based on the condition, if the condition is true, it's going to print some values or execute some values, and if the condition is false, then it's going to ignore some statements. If the condition is true, some statements will be executed and ignores when the condition is false. There are different types of selection control structure in C++. These are if statement, the if control structure, if else, and switch. We'll talk more on these different control structure, and I'm going to write different programs for these different selection control structure in some videos and coming videos that I'm going to upload to the YouTube. So there you will learn all these things. Next is the example. Suppose a program inputs the marks of a student and displays a message on the screen whether the student is pass or fail. So here our main objective is that we have to input some marks, okay, in marks variable, and then we're going to give condition, and then based on the condition, if the marks is greater than 50, it should print us, the program should print us pass, or the student is pass. Else, if student has got less than 50 marks, then it's going to display as fail. Now the program checks the marks before displaying the message. Now it is an example of the selection control structure. Let's see the flow chart, and then I'm going to write program for this as well. Here this symbol is used for the condition. So if the condition is true, okay, the control will transfer to this statement, statement number 2. and then the program will be terminated. If the condition is false, then this statement will not be executed, remember, but rather the control will transfer to this statement and this statement will be executed. Let's try to write this program which I have explained in this example. Let's try to run this program and then work on this program. It says that you have to input marks. So marks is variable, okay, int marks, and I have to print a message so that please enter student marks, okay, and in line marks, okay. If marks, the condition was that if the student marks is greater than 50, then it should print what? It should print cout student is passed, else student is failed. Okay, so based on this condition, now this is the example of selection control structure. In this statement or in this program, some statements will be ignored and some will be executed based on this condition. Okay, so here we use this if statement, and this is basically the else. Okay, we are going to learn more about these things, but for now I'm just giving you an example of the selection control structure, that this is how the statements are selected, okay, based on the condition. So first of all, I have declared a marks variable, and then this message will be printed on the screen. The program is going to wait for the user until the user inputs some values, okay, whatever value the user enters, that will be stored in marks, and here marks, the value which is stored in marks will be compared with 50. If the condition is true, this statement will be executed. If the condition, this condition is not true, then this statement will not be executed, but rather the control will directly jump to this else part and this statement will be executed. Let's try to run this and see the result on the screen. Now you can see where is the control right now. The control is in this statement in the CN. So the moment I enter 51, because here 51 is greater than 50, that's why 51 will be stored in marks variable, and then here with this condition it is going to evaluate to a single value, okay, or to some result. For example, result can either be true or it can be false. So 51 greater than 50, okay. Now in this case condition is true. When the condition is true, this statement will be executed, but this statement will not be executed. Let's try to enter, press enter. Now you can see only this statement is executed, student is passed. This statement is executed. Now let's try to make the condition false and let's try to see the result on the screen. Again, the control is where? The control is here. So I have to put a value. Assume that I put 49. Now 49, it's going to evaluate, this statement is going to evaluate the condition 49 greater than 50. It means that 49 is not greater than 50, the condition is false. So this statement will not be executed. The control will directly jump to this statement, to the else part, and this statement will be executed. So when I press enter, you can see this statement is ignored or it is skipped, and this statement, the else part, is executed. Why? Because the condition is false. That's why it is not going to print this result. The program is not going to print this statement, but rather the program is going to print the student is failed. Fine. Now I hope that you have got this selection control in quite a proper way. Now this is what we discussed. The third type of control structure is repetition control structure. Remember, repetition means when you do something repeatedly for a number of times. For example, we can we can eat the food on daily basis, so there is repetition. We can go to university on daily basis. We perform prayers 5 times in a day. This is basically repetition. So the same way you can implement this logic in programming as well. When you want to when you want to execute some statement repeatedly for a number of times, so in that case, that control structure would be called as repetition control structure. Now repetition control structure, these are the points. A repetition control structure executes a statement or set of statements repeatedly. You can print one statement uh, some number of times, or you can print the entire group or set of statements for a number of times. It is also known as iteration structure or loop. This repetition control structure is also called as loop. In next chapter would be allocated to the repetition control structure or to the loop, and there you would know that how can we use loop in our program. Now, there are different types of repetition structure in C++. They are basically while, do while, and for. Now while, do while, they are basically the keyword, okay, and we normally use them in our program if we want to print something or execute something repeatedly for a number of times. Now this is the example. Suppose we want to display a message, and what is message? Message is I love Afghanistan on screen for 10 times. Suppose we want to print this statement I love Afghanistan on the screen for 10 times. Now there are two ways. It is time consuming to perform this task using sequence control structure. By using control structure, you have to write 10 separate cout statements. Cout I love Afghanistan, cout I love Afghanistan, and tell 10 statements. But you can do this thing in one statement as well, and that is to use this loop. However, it is very easy to perform this task using repetition control structure. A single loop statement can display the message I love Afghanistan for 10 times. We will see this. I'm going to write a program on this in order to show this practically. Now this is basically the flowchart for repetition structure. This is repetition control structure. This is the flowchart or the diagram. This is how the flow of the statements are executed. Remember that if the condition is true, the control will transfer and it's going to print the statement. Whatever the statement would be, that will be printed, and then the control will back go to this condition. Okay, will again go to the condition. It's going to check this condition. If the condition is true, this statement will be executed, and it's again going to check the condition. What if the condition become false? Now if the condition become false at first time, then nothing will be displayed, okay. But if the condition is false on certain value, then the program will be terminated, and whatever you have written in the program, that will be displayed for specified number of times. Let's try to write a simple program by showing this repetition control structure. Integer a, okay, yes, a. Or first of all, let me write this thing cout I love Afghanistan using sequential structure, okay, using sequential structure I love Afghanistan for 10 times. Now how can I do this? I can do this by separately writing different statements separately, okay, 2, 3. Now this is the task that I have to write this I love Afghanistan for 10 times. 5, 6, 7, 8, 9, and 10. Okay. Now this is quite time consuming method. If you are using sequential structure here, then it's going to be quite time consuming. We will learn more about this when we are going to study the loop. But for now, this is just an example. See, 10 times I love Afghanistan will be printed on the screen. But what if I can use a more easy way, and that easy way is to use some loops, okay? So in one statement you can write all these different statements, so the output would be same. let's try to run this, let's try to use here, declare a variable, and I'm going to use for loop. This is one of the loop that we use in our program. We start from 1, okay, I less than or equal to 10. So because this is condition, I less than or equal to 10, until this condition is true, the statement will be executed, and this is called increment operator. Uh, I'm going to teach this increment and decrement operator as well in coming lecture, but for now it's going to add the value of 1 each time this body of the loop is executed. Let's try to write the same statement, I love Afghanistan. So now what could be the result? The result could be simple. Now you can see the number of statements are reduced here. The line of code is actually reduced here. So in one statement, this entire program can print as I love Afghanistan for 10 times, because here we put the condition 10 times. So if we run this program, the result would be same. You can see the result is the same. Even you can put this 100 times. You can change the condition to 100 times, then this statement will be executed for 100 times. You can see this is for 100 times. Or let me print the value as well in order to show that this is printed for 100 times. Run this program again. Now you can see 100, I love Afghanistan. This is 99, I love Afghanistan. And this was basically the first time it printed the statement I love Afghanistan.